to get this kicked off. Okay, we are recording. We are live. It is our exam review. Since it invariably gets asked, ooh, I got a typo. All right, off the bat. That's supposed to be homework 3.1. That's supposed to be homework 3.1. Oh, God. That's horrible. But I'll get that fixed. But yeah, homework 3.1 isn't due until next Friday. You all don't have any homework due today. You don't have any homework due on Wednesday. And that cross-product homework isn't due until Friday. The idea is that I just want you all to focus on the exam. So let's talk about the exam. First off, before we do, though, a couple housekeeping items. I've updated the attendance grades. And this weekend, I had a student ask me about that. And I found like kind of a glitch on the attendance grades to where it was like double counting some things. So I corrected it, and what ended up happening was if you had perfect attendance, it didn't matter. But if you had missed a day or something, just about everybody's, or I think everybody's attendance grades went up slightly because it was double counting the attendances. So I apologize for that, but everything that's there now is correct and accurate and up to date. Now, it invariably gets asked, just so I want to make sure everybody's on the same page. The attendance is worth 10% in this class. The homework's worth 30%, and we have 4 exams. Each of those worth 15%, just so you are aware of how much the exam is worth. Before we talk about what's covered on the exam and let you all ask whatever questions you want about topics and what have you, I want to talk about the logistics, specifically about how we're going to operate the exam, the scheduling, what's approved, what's not approved, the format, all that jazz. So let's get that out of the way first. Okay, so let's talk about the schedule. Okay, so the exam is going to open at 1 p.m. On Wednesday, and it is going to close at 2 p.m. on Wednesday. It is designed to be 50 minutes long. Now, I'm opening it from 1 to 2 to give like a little bit of a buffer in case there's like, you know, connectivity glitches or whatnot. But the exam is designed to be 50 minutes long. One other thing about my exams, I mentioned this actually during the first lecture, but I'll go ahead and mention it again. I tend to design my exams based off of kind of like what I call a rule of 3. So once I finish making the exam, I take the exam myself. And so to keep the math simple, if the exam is 1 hour long, then I need to be able to do it in 20 minutes. So I cut the time in. If it takes me longer than 20 minutes, then I cut material out of the exam, because I've never really been a fan of doing a time crunch exam. Okay, so I've always, I don't like that. I don't want there to be an instance where you feel rushed. Okay, now let's talk about how the exam is going to be implemented. What I'm going to do on Blackboard is this. I'm going to have actually 2 forms show up on Blackboard. Okay, so at 1 p.m. On Wednesday, the first thing you're going to see 2 things. You're going to see this, which is the actual exam itself. That is the test. So you'll go there and you'll take the test. You know, you'll have some paper on your own to do some scratch calcs and whatnot, and you take the test. That will open at 1 and will close at 2. I also have this upload form here. The idea is I'm a partial credit guy, so if you get a question wrong, to me it's not, oh, it's wrong, minus 20 points. I'm going to look at your work and see what you did. So I have a separate place where you can upload your work. That upload form is going to close at 3 p.m. So the reason I did that is because I don't want you to feel like rushed, like, oh, God, I don't have time to get the PDF submitted. Like, just take the exam, you know, and submit the work. Now, let's just, you know, hold on. Will the work we show be like extra credit on the ones we missed? Well, it's not extra credit. It's partial credit. So if it's a 20-point problem and you get it wrong, that doesn't mean it's minus 20 points. I'm going to look at your work and see, well, maybe it's not minus 20 points. Maybe it's only minus 2 because you got everything right, but that positive should have been a negative. So I'm going to review your work and I'm going to see like what you did wrong, and I'm going to give you partial credit as a result. Does that make sense? Yeah, that is true because I wouldn't have anything to go off of. So that you really do need to upload the work. But the point is, like, I'm giving you extra time to upload the work. Now let me be clear. What I don't want to have happen is you took the test and you reported an answer, but then you uploaded the work, and I look at the uploaded PDF and I'm like, this is nothing like the exam because they took extra time on the exam. So don't do that, ethics and honor system and all of that. Okay. So you're going to have, so the upload form will close at 3 p.m. That way you won't feel rushed to upload the PDF. Let's talk about the operation. Okay, so when you click on the test is a forced completion test. So once you start the exam, it has to be completed in one sitting, okay? It is a timed exam with an auto submit feature. So the way it's going to work is, you're going to start taking the exam. It will save and submit automatically after 60 minutes has expired. So whatever you have typed into the fields, make sure that you've got that correct and ready to go. I do have it set up to where the questions appear all at once, and I do that so that you can review your responses before you submit. It makes it a lot easier to scroll up and make sure that you've got everything filled out the way that you wanted. As for approved materials on the exam, I mean, this is an online class, so I'm going to be fine with this being an open book class or an open book exam, an open notes exam. You can use any resource that's on Blackboard. Okay, and what I mean by that are the lecture notes, I mean the recordings, the YouTube recordings, I mean the homework solutions. You can use all of that. I don't have a problem with that. The one thing that's my draw the line in the sand item is you're not permitted to give or receive aid from another individual, and that includes online forums and Chegg and stuff like that. I mean, you've got more than enough material to negotiate the exam. You can pretty much use anything that I've given you. You just can't use another person. It's just you. Okay. So yeah. As for the format, I'm currently in the process of making the exam, and it's mostly complete. I need to go through and do the exam and then tweak it. But there will be 4 to 5 short answer conceptual questions, which will probably only be worth maybe 15 to 20% of the exam. It's not going to be a major chunk of the exam. The most of the exam is going to be from the computational problems, and there's only going to be 2 or 3 computational problems. But I mean, as by now that any one of the homework problems can cover a wide variety of topics. So this class is kind of built on itself. So we really only need 2 or 3 problems for the exam. And again, I'm a partial credit guy, and I don't want this to be a time crunch. So if you can cover, if you can do the stuff on the that we've done up until now, you will be good. Now, one other thing in terms of taking the exam, please type out an answer for every question, even the computational ones, because it helps out with grading. Because what I can do is I can download all the responses, and I can just look at everybody's response to question 1, look at everybody's response to question 2, look at everybody's response to question 3. But if you don't type that out, it makes it a little more difficult. So don't just answer the question on your scratch work that you scan and submit. Type out the answer, because that does help out a lot. Now, before I'm going to open it up to questions for everybody here in a second. Let's talk about the topics on the exam. So what are the topics on the exam? So let's talk about the fundamentals. So you need to understand classical motion and Newton's 3 laws, be able to compute the weight of an object, be able to convert units and perform dimensional analysis as appropriate. And in terms of math, really the only math that we use is algebra and trig. Calculus and whatnot will show up later, but not really for this exam. The big, topic is the statics of particles. So make sure that you understand vector properties. You can add vectors using either graphical approaches, trigonometric approaches, or addition by vector components, and that you can apply equations of static equilibrium to 2D systems and 3D systems. And so with that means you got to be able to solve 2x2 systems and 3x3 systems. In terms of relevant equations and formulas. So I put this slide on here. This is the expression for converting mass to weight using the acceleration due to gravity. I put some base units on this slide. I synthesized all the super important stuff with trig and just put that here. So these are the trig preliminaries that I think you kind of need to be aware of. Your law sines, law cosines, basic relations for a right triangle, and then conversion between rectangular and polar. make sure that you understand the basics of vectors, just, you know, what it means to add one or two vectors together, what's the deal with I and J, and how can you write a vector in I and J format, and that you understand the basic expressions in 2D and 3D. And in terms of like formulas and things like that, that's about it. I mean, because everything that we've done from day one up until now can, I think, pretty much be synthesized in these slides. Okay. I am now done. There have been some questions in the chat already about going through some particular homework solutions and homework problems, but I want to sort of open it up and see if there are any quick questions or anything that I can respond. The floor is yours. That is good. Okay, let's take those one at a time. So on the conceptual questions, what will the questions be like? I don't know what all I don't want to tell you what they are, but what I'll say is this. First off, they are designed to be short. You know, they're not essays. They're short 1 to 2 sentence questions. If you're typing more than like 1 or 2 sentences, you're probably doing something wrong. It could be that. It could be definitions. It could be explanations of how to do a procedure. Let me say this. If you generally understand what we've been doing up until now, I really don't think the conceptual questions are going to be terribly difficult. I will go ahead and tell you to illustrate a bit. There are a couple that are just definitions. Okay. Not all of them are, but some of them are. Let's see, what else? I'm trying to think what they'll be like. I don't know what if I can answer anything beyond that, because if I do that, I'm going to start telling you. I'm going to tell you what they are. If we have a question about the direction of an angle, should we type what quadrant it will be in? That's a great question. Long story short is anything that needs to be typed out like that, I'm probably going to help you out from the typing standpoint a little bit. In other words, I might say type it out, you know, in this fashion. I don't want to like tell you how the question is written, but suffice it to say that I thought about how to reduce the confusion for you and for me on the grading standpoint in terms of stuff like that. So I did think about that a bit in advance. Hold on for a sec. What was that? I hope that answers your question, Mr. Ashworth. And I guess, Ms. McDaniel, I answered yours too. Good deal. Any other questions before I start going to the questions that were mentioned in the chat earlier before class started? Okay, what I'm going to do is, so there were some questions in the chat. Ms. Chapman wanted to go over a couple of homework solutions, so I'm going to do that. Mr. Page, you had asked a question about angles. While I'm going through those, I want you to think of a particular problem or a particular thing you want me to discuss. And as I'm going through this, don't hesitate to go through any questions and whatnot. Okay, so let's start off with homework solution 2.4. Okay, all right, 2.5. So I'm going to do that one here in a second. Okay, so here's the solution. Actually, let me pull this up. Let me share the screen. I might be able to just share the window. Yeah, okay. So here's the homework solution to homework 2.4. This was requested at the by one of the students. So Ms. Chapman, I believe. Okay, so with this problem, we have two cables that are two elements that are holding up a weight that's acting downward, and what we need to do is determine the tension in those cables. Now, right off the bat, we have that the object was given as a mass, so the mass that was in 200 kilograms needed to be converted into a weight, so mass times gravity gives us a weight of 1962 newtons. So if we were to write the weight as a vector, we would write it as weight equals basically negative 1962 J. Now, here's the free body diagram. The free body diagram angles are measured with respect to the horizontal. So, for instance, TBC, it's just going to be that the magnitude of that tension, and then it's going to be the cosine of 75 degrees times I, and the sine of 75 degrees times J. So here you can see that's how I've got this written right here. So TB is the vector is the tension times the cosine of 75 times I, and then the tension times the sine of 75 times J. And it's the same story here with AC. The only difference is the terms are negative. And the reason that the terms are negative is because the vector is operating in the third quadrant. So if here's your origin, you can see that tension AC is negative in the x-axis and negative in the y-axis. Hence, why I have the vectors drawn in the negative fashion. And so when I sum forces in the x direction, what I'm doing is I'm basically saying, okay, for the x direction, just sum up all these. Okay, and for the y direction, sum up all these. Okay, and so for the x direction, I get negative TBC times the negative cosine 15, TBC times the positive cosine of 75. That adds up to be 0. And then negative TAC sine 15, positive TBC sine of 75, and then negative 1962 equals 0. And so all I do is I take these equations and I say, okay, let's take all the constants, move them over to the right side of the equal marks, and then just write them in matrix notation. So this goes in the top left corner, this goes in the top right corner, this goes in the bottom left corner, this goes in the bottom right, and the negative 1962, I move that on over to the right side of the equation, and then when I'm done there, I've got two equations, two unknowns. Plug that into my Casio. There's my solution. As for problem 249, I can go through that in detail, but really that problem is just kind of, I guess the best way of saying it is it's just more, because it's basically just this problem kind of done over again. The only difference is, give me one sec. I saw that in chat. I'm gonna answer that here in a second. The only difference is that instead of for this free body diagram, instead of 3 vectors, there are 4, but there are still 2 of them that are unknown. This is a 2-dimensional problem, so there's always going to be 2 unknowns. And those 2 unknowns are tension AB, tension BC. We have 4 vectors, but it's the same process. When we plug a matrix into our calculators on the exam, do you want us to note that? Yes, I do. Let me say this, in terms of grading, you're going to make my life a lot easier if you just point out something like this right here. This is what I plugged in. Instead of, see, if you look at, let me blow this up a bit. If you look at this solution, you can see how, we go from the free body diagram here to the description of the vectors here, to applying the 2 equations of equilibrium here, to my matrix system that I can plug in my calculator. It's not just, I don't go from 247, oh, I plugged it in my calculator, here's the answer. There's a lot of detail that shows how I get from point A to point B. But once you get to that point, the point that's highlighted in blue right now on the screen, I'm okay if you just plug and chug plug and chug that. That's no problem. Now, before I open it up generally to a bit more, a few more questions, Miss Chapman originally asked me to go through this. Now, I went through the first problem. Do I need to go through the second one, or is there something I didn't cover, anything I missed? Like, let me know. You're good. All right. My camera is deciding to be funky. If for some reason I have connectivity issues, let me know. Hold on for a sec. Give me one sec. Is finding the resultant of F and P an acceptable way to find the tensions as well? Are you talking about on this problem? So the short answer to that question is no, because if you find, well, let me elaborate, and then maybe we'll be speaking the same language. So if what you are talking about doing is taking F and P and then finding a resultant of those two forces, and then taking that resultant and then doing what was done in the last problem, you know, breaking everything up into X and Y and two equations, two unknowns, then what you're saying is, yes, that's probably fine. But what you can't do is just find the resultant of F and P and then say, oh, that's my answer. That's not your answer, because all that does is take F and P and express them as just one force. It doesn't tell you what the tension in cable AB or the tension in cable BC is. The only way you're going to get that is to apply your equations of equilibrium and solve the system. Now, did that answer your question? Okay, good. All right, let's talk about solution 2.5. This one I know was probably a bit tricky. I know that of all the homeworks that we've done this semester, this is probably the one that I had the most traffic on Microsoft Teams, if it were. But it's one of those things about pulley problems, is that they're so easy that sometimes they're hard, if that makes any sense. So the first thing I want to point out is this, okay? With this particular problem, you had a pulley system such that you had one rope going up and to the right, and then you had two ropes going up and to the left. So you can express that as follows: just a P vector going up and to the right, a 2P vector going up and to the left. Now you have really two unknowns for this problem: the magnitude of that vector P and that angle alpha. So it's still a two equations, two unknowns problem. It's just, instead of two unknown forces, it's one unknown force, but it's the force and the orientation. Now, I have here that there's an angle alpha, but there's also an angle, like here's angle alpha, but there's also this angle beta. But beta you can solve for, because the problem told you that for that cable, you know, it went 3/4 of a meter to the left and 2.4 meters up. So you can determine that angle beta, and if you've got that angle beta, you can then say, I can determine my expression for my vector. Now, notice how I've got the I term as negative, but the J term as positive, because the vector goes to the left and up. So the X component is negative and the Y component is positive. As for the P vector, the one that goes up and to the right, both of those components are positive. Same thing with the weight vector. Convert that to that mass to a weight, and then now we have you know, W equals, you know, component times J, negative because it's going downward. And then we have our equations of static equilibrium. Now, what you find on this particular problem is that instead of getting this matrix system, what you find is you get, if you just take the sum of forces in the X direction, you get this, okay? And so all that comes from is just taking, you know, these equations and adding up all the components that are in front of the I's. that's it. So that plus that. And so what happens is you get this equation right here. Well, if you look at that equation, I have, it's basically like saying, you know, almost, you know, like 2x plus 3x or something. Out the x's. Well, in this instance, you factor out the p's. Both of those terms are multiplied by p, so you can cancel those out. And so you just get that the cosine of alpha is 2 times the cosine of 72.65 degrees. You can solve for the alpha term pretty easily. And so you get alpha is 53.38 degrees. And from there, it becomes a pretty plug and chug problem. What I did is I said, okay, I've utilized the sum of the forces in the x direction equation. So why don't I utilize the sum of the forces in the y direction equation? So I added up all the terms that were associated with my j vectors, all the y coefficients. I then just plugged in my term for alpha because I now knew that, and then just solved it out. And then when it was done, you know, it's just a little bit of algebra, and you get like P is like 700 some newtons, 723 newtons. Now I know, Mr. Page, you asked this question because of the trig, like it was the trig that you were interested in. So the remaining problems really don't have anything to do with the trig. So did I answer your question there? Are there any questions further from anybody else? Good deal. No problem, no problem. Any other questions? Like I said, I can pull up anything, just let me know. (2.67b). Okay. Okay, yeah, on this one, oh. Let me get to that question here in a sec, Mr. Dare. I won't forget. This one might be a little easier to add, to do on the board. Let me do this one on the board. Okay, so let me see if I remember that problem. I think it was like this. So I want to look at scenario A and scenario B. Okay, so scenario A, you had a box, you had, you know, a pulley, and then it was basically just, you know, here was your wall, and then you had a rope here, and then, you know, you were yanking on that rope like that, okay? And so, you know, whatever this weight was, well, whatever, you know, some weight W, okay? If I look at just this pulley, I ask myself, how many ropes are going through that pulley? Well, here's the pulley. I have, you know, a W force going down, and I've got, you know, some tension going up here and some tension going up here, okay? So in the end, it's still 2T going up and then W going down, okay? So 2T going up, W going down, you know, your tension is W over 2. Now for this one, for scenario E, we still had our pulley system, but it was a little different. So kind of went like this. So we had a rope going here, but then we also had, I think it was some pulley like this, and the rope kind of went like that. And so the question is, okay, how is this scenario different than this one? The answer is they're actually not that different, because again, we're still looking at the equilibrium of this pulley here. And so if you look at this pulley, there's still only 2 tensile forces going up and 1 weight going down. See, here's the thing. I know, like, okay, imagine if this rope was like all the way down here, you know, or imagine if there was another pulley that it went through and you were pulling it like that. In the end, this pulley holding up this box I cut that. There's only 2 tensions going up. So you could take this rope and swing it, as many ways as you want. There's still only sort of 2 ropes, 2 tensile forces on this particular pulley. You only start changing things when the ropes start going back and attaching to that pulley. See, for instance, if you look at if you look at problem E had a little bit of a funky pulley system, but all of the, this whole object here, this was all one object, that pulley system, and within that row, or within that pulley system, there were 1, 2, 3, 4 ropes. Okay. Did that answer your question? I was hoping that this sort of like, system over here that I drew here on the board did. While you're chewing on that, let me answer Mr. Dare's question. So Mr. Dare asked, will the 3D diagrams on the test be easy to tell? Good. Will the 3D diagrams on the test be easy to tell the dimension, magnitudes, and directions? The short answer is they're intended to be. I mean, 3D is always something that can be kind of difficult to determine. The easiest trick that I have found when it comes to 3 dimensions, let me see if I can... give me a sec. Let me see if I can find something to go off of. Let me try homework 2.6. Let's try this one. Okay, let's take this image, just because it really doesn't matter. But this would be a good one for discussion purposes. So you're correct that 3-dimensionally, it can be kind of difficult to determine, like, okay, what's your X component, what's your Y component, what's your Z component, etc. The best advice I can give you for trying to determine your X, Y, and Z components in 3 dimensions is to truly handle them one at a time. If you try and look at, like, okay, let's take vector AB. If you try and just look at vector AB and say, oh, it's just 40i, negative 45j, and 60k, that can be kind of difficult. Instead, what you need to do is trace each axis one at a time, okay? So let's take vector AB, okay? Now let's start off with the x-axis. First off, what's the x-axis? That's the x-axis right there, okay? I'm going to get to your question here in a sec, Mr. Davis. Don't worry. All right, I won't forget. Okay, let's take the x-axis. First off, the thing to point out is that the x-axis. Let me see if I draw on this. No, I can't. Maybe I can. Let me try tools. That's going to be too complicated. Oh my, it froze on me. I'm sorry, give me a sec. Okay, we're back. All right, so the first thing to do is to take each axis one at a time. So let's start off with the x-axis, okay? And then maybe the next best thing to do is get you like a protractor or scale or something like that. And since I know we're doing this on the screen, maybe try and take care and make sure you're not scratching up the screen, but hold your protractor in the direction of that axis and only follow that line. So for instance, from A to B, like how far are you going in this direction? And then flip it on the y-axis and say from A to B, how far are you going in this direction? And from A to C, here's the z-axis. So how far are you going in this direction? Like actually break out like a physical rule or a physical object and sort of hold it onto your screen parallel to each axis, to the x-axis, then the y-axis, then the z-axis, and then say, okay, follow along that line, and along that line, how far you go. Now, along that, Mr. Davis asked, for a problem like this, where would you recommend putting the origin and the axes? Two answers to that. First is, in terms of where to put the axes, for a test, I'm probably going to tell you where, like, which is the X, which is the Y, and which is the Z. And the reason is there's probably like 8 different ways to orient that, and they're all correct. And then now I've got to grade 8 different exams. So I'm going to probably tell you, okay, this is the X direction, this is the Y direction, this is the Z direction. Okay. As for like where is your origin and how you draw your distance vectors, remember what we're testing is the statics of particles. Okay, that's what our test is on. That's exam 1. It's on the statics of particles. And what that means is when you're looking at a particle, all the forces go through the same point. And so you're asking me where to put the origin. And my response would be, well, in statics of particles, all the forces go through the same point. Does that make sense? So that particular point would probably be a good place. Now, let's go back to Mr. Darrow. Mr. Darrow, did I answer your question? Did that help out? Good. All right. We still got, probably like 15 minutes. I mean, I don't want there to be any time wasted. Oh, I'm dropping triangles all over the place. All right, hold on. Give me a sec. Stop this. Okay, what was it? I'd like to see 2.7 setting up the sum of forces to the end. Okay, hold on. All right, so first off, this solution just got posted today, so like I just turned it on, so there's a good chance that you didn't see that, and that's okay. That's on me. But we didn't get it graded until last night, so. Okay. All right. So first thing is your distance vectors. Okay. And so again, like I responded in the last question, just follow each axis one at a time. So for instance, AB. Okay. AB is the horizontal axis. It goes left to right. So from A to B, left to right, you're going left. And so, think that's that dimension. So basically we're talking about that length right there. And so you can follow that and see that that's the 450. So that's where the negative 450 comes into play. Yeah, from a 3-dimensional perspective, this is like the hardest part, and I'll be the first person to admit that. But once you get this, the problem really does become pretty rote and pretty mechanical. Once you get your distance vectors, the next thing you do is you do your unit vectors. And so your unit vectors are just taking each one of those and dividing them by their magnitudes. So we have our distance vector AB, so we can get lambda AB by taking it divided by its magnitude. And so that's what I do right here. Same thing with AC and AD. And so these are your unit vectors. Oh, right here. Like I said, with unit vectors, you kind of need to have like some degree of precision. I think that 4 to 5 decimal places is probably fine. If you want to store those values in your calculator and just like copy and paste them when you do your 3x3 system, that's fine. If you want to just write them out on the page, that's fine too. But again, make sure you've got a little bit of precision there, like 4 to 5. 6 is probably fine too, but I don't think you need to go anything past that. I mean, this is engineering, so I don't want to say close enough is good enough, because I mean, we do need to be accurate, but proportion matters. Okay. Now, here's the 3 unit vectors. Maybe if you wanted to be super formal, you could say, well, there could be a unit vector for the weight, but that would just be like negative J, would just be downwards. So we have, here's our force vectors. Now, here's the thing. We know the magnitude of one of the cables. We don't know the magnitude the other two, or the weight. So it's still a 3 equations, 3 unknown situation. So with the one that I do know, this one right here, this TAD, what I do is I take the known magnitude times the unit vector. And so this answer that you get right here, it ends up becoming like nice, pretty round numbers, because if you follow all those decimals out and then multiply them by 4.3, they come out as nice whole numbers. But here's what you get. You get 2.5 kilonewtons plus 3 kilonewtons plus 1.8 kilonewtons, I, J, and K respectively. The rest of them, however, are symbolic. Okay, so what I do is I write them out like this. I always recommend that you sort of write them like spaced out like this, like a pile of junk times A plus a pile of junk times K plus a pile of junk, or sorry, pile of junk times I, pile of junk times J, pile of junk times K, and then write them out kind of in this grid fashion, because when you sum forces in the direction, you're just adding up all of these. These are the sum of the forces in the Y direction. These are the sum of the forces in the Z direction. Now, when it's all said and done, if you want to write this, if you want to use your 3x3 system solution, you can, and it will work, I promise you. But if you actually just take a step back and just kind of look at what's going on, like let's start off with some of the forces in the X direction. If you sum forces in the X direction, all you're going to find is that negative 0.86 TAB plus 2.5 kilonewtons has to equal 0. So you can actually solve for TAB right now without breaking out your 3x3 system solver. And you'll get TAB is like 4.167 kilonewtons. And so you're like, okay, I got an answer here. Okay, well, what about summing forces in the Z direction? Well, if I sum forces in the Z direction, I can solve for TAC directly. And there you go. I got TAC is 3.825 kilonewtons. Now, give me 1 sec. I'll get to that, Mr. Dare. Now, when you sum forces in the Y direction, you do have 3 unknowns, but you already know 2 of them from the other 2 equations. So what I did on this problem, this is basically solving those system of 3x3 equations by substitution, because instead of breaking out the matrix solver, I already know 3 of them. Now, again, to be absolutely crystal clear, you can set this up as a matrix and it will work. You will get TAB is 4.167, TAC is 3.825, and W is 9.71. But for this particular problem, there's really not a point. You can just plug and chug. Did that answer your question? Shading of this problem's diagram confused me. That's why I've asked. Okay, so I can appreciate that. Again, 3D always is kind of difficult. And again, the best thing to do is to simply follow each axis one at a time. For example, let's take the y-axis. Okay, the y-axis acts up and down. Okay, so for the y-axis, ask yourself, how far is it from A to B? Well, right over here, that's 600 newtons. What about A to C? Again, we're talking about that same dimension here, 600 newtons. Same thing with A to D. Again, I find that the easiest thing to do in 3 dimensions is to not try and to handle the entire vector all at once, or the entire system all at once. Take each direction one at a time. Take the X direction, then the Y direction, then the Z direction. For example, like AC, you can see AC right here. You can see how, if you follow that, it goes through the axis there, hence why AC has a 0 component here. I'm sorry if I'm clicking all over the place, because it can be kind of difficult to do this on PDF and not make the whole page blue. Setting up the W in the matrix threw me off because I was thinking about gravity. Well, remember, if you're solving for a weight, that already has gravity incorporated in it. So you don't need to, the only time that you ever need to throw in your G term is when you're given a mass. Or the flip side is if this problem asked for the mass of that object here, if the problem asked for the mass of this object, then what you would be doing is solving for the weight, and then take that weight and dividing it by g to get the mass. Otherwise, you'd be solving for the weight directly. And since, remember, once you're dealing in weights and forces, you don't have to consider gravity at all because it's already built into it. Like, for instance, if I, however much I weigh, if I weigh like, 210, 220 pounds, that already takes into account gravity. So you don't have to consider that. Can you go over the dimensions for 2.7? I think okay. Well, we got a couple questions. I think I missed them. I'm sorry. I don't know what happened because they just popped up. Okay. So on that problem, okay, hold on. I missed. Let me miss a couple. Let me first off, Carrie, did I answer your question, or is there something specific that I missed? And then I see Mr. Armbruster's question because I think I accidentally skipped that, and I apologize. Okay, good. Okay, Mr. Armbruster, which homework were you talking about? 2.6. Okay, hold on. Okay, now which dimension are you talking about? On that problem, why would the I component be 40 and not 60? Are you talking about the AB? Okay, the reason why is because we're talking about the distance from A to B, not from the origin to C. Okay, so you ask yourself, from A to B, how far do you go over in each axis? So we'll start off with the x-axis, and so the x-axis goes this way, like if you follow my cursor. So this way, from A to B, we've got that 40 inches. I'd say, and so to further build upon that, to go from A to C is 40 plus 60, hence why it's 100 here. That's a good question. We got about 3 minutes. We still got time for a couple other quick ones if we've got any. Oh, I spilled my coffee. I'll have to clean that up. But don't let that hold you up. If you got any questions, please throw them out there. Any questions? Any at all? Do we meet Wednesday? Not here. Not in Collaborate. You're just going to take your exam. On Blackboard, the exam will open at 1 p.m. and it will close at 2 p.m. So there won't even be a session pop up. Now, again, like I said, you can use any of the materials on Blackboard, but you cannot use each other or any help from anybody else. But between the lecture notes, between the homework solutions, between your book, your notes, the recordings, you should have more than enough material to negotiate the exam. Would it be a good idea to review all the homework or just specific ones? I guess the best answer to that would be all of them, because if I said, oh, only review this homework, then I'm telling you what's going to be on the exam. So I would say all of them. But with that, what I'll say is this class kind of builds on itself. So, for example, if you take homework 2.7 and then compare it to homework 2.6, okay? 2.6 was adding vectors in 3 dimensions. 2.7 was static equilibrium in 3 dimensions. But static equilibrium in 3 dimensions incorporates adding vectors, which you did in the previous assignment. So it does kind of build on itself. So it's like by understanding homework 2.7, you've done 3-dimensional adding of vectors, you've solved systems of equations. So there's a lot of stuff in that assignment that you do in other homeworks. I'm not saying don't review all the other solutions, but I'm saying that it does kind of build on itself. So the more that you understand the later stuff, probably the better chance you have of understanding the earlier stuff. Did that answer your question as best I can? All right, well, look, we're at 1:51. I think we're going to have to call it. Again, the exam will open up at 1 p.m. on Tuesday, or on Wednesday, sorry, Wednesday. If you all have any other questions, you can send them through me, or send them to me via Teams, and I'll do my best to answer them if I can. With that, I wish everybody the best of luck on the exam, and we'll see you in class on Friday. So best of luck.